Hey guys, so in today's video we're going to be talking about systems of equations. And a system of equation is a collection of two or more equations, just like these guys, each containing one or more variables. All right, this is stuff that you guys have seen in the past multiple times. This will just be a good recap, and we'll end the video to start talking about some matrix notation. All right, so let's get started. Okay. So the first method of solving a system of equations is substitution. And substitution goes back to the ancient times. Nobody knows where this method actually came from way back in the day. I don't know. Just a little history fact is in the book. Felt like sharing it. But anyways, substitution, the way we do that is here, we'll get y by itself. Okay, so that's our first step. So we'll just say 2x plus y equal 5. Subtract the 2x over. We'll get that y is equal to negative 2x plus 5. All right, so now we've got y by itself. Now what's the next step? Well, the next thing we do is substitute that equation and for the y into our second equation. So we'll have negative 4x times, plus 6 times is equal to 12. All right, so now we multiply that 6 in and combine like terms. So okay, so now we get the x's on one side and the numbers on the right. Okay, now the only thing we have left to do is divide by this negative 16. And the way that I got 9 over 8 is I just reduced the negative 18 over 16. All right, so now that we have our x, we have to figure out what our y is. So we throw the x back into our equation. Or you can even throw it in this one. I'm going to choose the top one just because it looks easier. Okay, so then we'll have 2 times whatever x was, which is 9 over 8, plus y is equal to 5. Okay, now we just have to solve for 5, so we multiply the 2 over. Okay, now this 18 over 8 is just equal to 9 over 4. If we simplify it. And so I'm going to subtract this 9 over 4, both sides. So we'll get y is equal to 5 minus 9 over 4. Now we can't subtract them, right, because 5 doesn't have a common denominator. So go into here, and if we do this at 5, it's going to have to change it to a 20, because 20 divided by 4 is just 5. And so we'll get that y is equal to 11 over 4. So those are our two answers. All right, now let's look at another method of solving two systems of equations. Another method is elimination. And the elimination method has existed for a long time, But Carl Friedrich Gauss, if you guys ever heard of him, he's the guy who actually made it a thing in around the 18th century. He was the one who wrote it in a textbook, and he made it his. I don't know, another interesting history fact from the textbook. Okay, but anyways, what is the elimination method? Well, a lot of you guys know it as the stack and add method. And the way that we do this is we look at either our x's or our y's and find a multiple that would multiply one equation to be the opposite of the other. So what I mean by that is, here if we're just looking at our x's, we want our coefficient in front of our x to be the opposite of the other x in the other equation. So here we have a 2, and the opposite of 2 is going to be negative 2. So down here, we're going to multiply everything by 2, so that way this 2 will be in front of that negative x, and so we'll have an opposite coefficient. And so this will end up being negative 2x plus 2y is equal to 6. All right, so we have that. Now if we were to do it with y, we'd have to make sure that we find the opposite of 3 in front of this y. And so to do that, we multiply by 3, or negative 3. Okay, but anyways, I prefer the x just because it's a 2, it's just less than 3, I don't know. Okay, so up top, it's going to stay the same. On the bottom, though, I'm going to multiply everything by 2 again. And 2x plus 2y is equal to negative 6. Okay, now that we've stacked it, we just add both these columns up, just like so. And so the reason that we find the opposite coefficient for the x is because we'll get these two to cancel out. And so we'll get 0x. So anyways, these cancel out. And right over here, we'll get 5y, which is equal to negative 5. And so we just divide by 5. Okay. Got a solution for y. All right, so now all we have to do is substitute that y is equal to negative 1 into our equation. I'm going to choose this one just because it looks easier. So here we'll have negative x plus negative 1, which is our y, is equal to negative 3. Okay, so we just get x by itself. All right, and so those are our two solutions. Now if you wanted to check to make sure those are correct, you can throw your x into your x up here and your y into your equation, and they should get you 1. So we'll have 2 times 2, which is 4, plus 3 times negative 1, which is equal to 4 minus 3, which equals 1. And so we're good. Anyways, elimination ends up being the preferred method of choice. And if we go back to this one, all we had to do here was just multiply this guy by negative 2 and do elimination. However, there are times when using substitution would be beneficial, like when you get equations where it's just x plus y is equal to 5. Well, then you can use substitution, because all you have to do is move that x over, and you're good to go. But anyways, the choice is yours. Either way will give you the same answers, but substitution is just more effective when there's not a coefficient in front of the y. Okay. Okay, but now let's talk about an inconsistent system of equations. So we've looked at systems of equations that have solutions. Let's look at one that doesn't have a solution. Okay, here let's solve this by elimination. So that's by -2. Just add the bottom row. Okay, anyways, these guys over here are going to cancel out. So we get 0. These guys are going to cancel out here, so we'll have plus 0, which is equal to -2. All right, but does 0 equal -2? And the answer to that is obviously no. And so since we're coming up with this solution right here, we can state that there are no solutions. Now let's look at something that actually has an infinite amount of solutions. And these are systems that are dependent on each other. So to start off, let's do this. Let's solve this by elimination. Let's multiply by -3. Oops, no, I'm sorry. Let's multiply by 3. We get 6x plus 3y is equal to 12. I'll write this one all underneath it. So when we do this, again, these to cancel out and these cancel out. So we'll have 0 is equal to, well, 12 plus -12 is just 0. Well, here in the slide before, we saw that 0 equaled -2 and therefore it had no solutions. But here we get that 0 equals 0, and this is true. Now what this is saying is that we can throw any x into here and get some y and have an infinite amount of solutions. Why is that? Why do we have an infinite amount of solutions when we come to this conclusion right here? Well, let's take a look at this. What if we took a -3 out of this, divide this by -3? Or better yet, just pull a -3 out of it. Factor out that -3. Okay, so when we do that, I end up getting 2x plus y is equal to 4. Look familiar? And now we can throw any x into this guy, and get the same y, and get the same answer. And so that's why we can throw infinitely many x's into this equation, or it can be the other way. And so how do we write our solutions for x and y? So to do that, we'll just look at our first equation here. 2x plus y is equal to 4. Okay, so our solution for x is just getting x by itself. And so here we'll have 2x is equal to -y plus 4. And so our solution for x is just -y 2 plus 2. Okay, now for y, we just try to get y by itself. So if y is equal to -2x, I'm just subtracting that 2x over plus 4. Okay, and those are our two solutions. And that's how we represent an infinite amount of solutions. So here when you get 0 is equal to 0, you have an infinite amount of solutions. And then here when you get something inconsistent, where like 0 is equal to -2, you'll have 0 solutions. All right, so now let's talk about matrices, which will be a way for us to organize a system of equations. So let's talk about matrix notation. And to get started, a matrix is just defined as a rectangular array of numbers. It's going to look like this, and you'll have some number here and here and here and here. So a really quick way of showing what it looks like, and this would be a 2x2 matrix. Okay, anyways, not the best explanation of the matrix of what it is, but let's go through an example of how matrices help organize their information. So let's write a matrix over this story right here. Suppose that 5 girls and 3 guys like country music, okay? And now that 4 girls and 6 guys like rock. Well, we can organize this information into a matrix by doing the following. Each row will represent music, and each column is going to represent girls or guys. So the first row, or first column, will represent girls, and the second column will represent boys. All right. And so for the music, we'll call this country, and we'll call this one rock. So here, country, there are 4 girls that like country. Let's just say 4. And here, there are, oops, I'm sorry, I took the wrong one. There are 5 girls that like country, and then there are 3 guys who like country. Okay, but now we move on to rock. 4 girls who like rock, and 6 guys who like rock. All right, and that's how we'd organize our matrix. It's as easy as that. Now suppose we wanted to organize our system of equations. Well, here, we're going to call this an augmented matrix. Now, what we're going to do is get rid of our x's and our y's. Remember, our x's can be like boys, and y could be like girls. Okay, and there are 3 boys who like the country music, or native 1 girls who like country music. But anyways, that's not making sense because then we're talking about native 1. Yeah, we're not going to be talking about native people. But anyway, so we'll write this to matrix notation. We write 3, so it'd be 3x minus 1y. We're going to draw a line right here representing our equal sign is equal to 4. Okay. And we do the same for the bottom. Now imagine that there's 1s in front of these guys, so just multiplying by them. So we'll have 1x, 1y is equal to negative 3. Okay, so what I'm showing you guys right here is just a way to organize your system of equations. We won't yet solve these yet until next class. Other than that, we'll post a couple questions within the blog for you guys to answer, and we'll see you guys next class.